Alright, so this video is focusing on problems that require the change of base property. So we're going to start with page 30, number 20. So basically we have 4 to the power of 2x times 8 to the power of x minus 1 equals 32. What you hopefully remember is that because 4 and 8 are not the same base, we have no exponent property that works if we wish to combine these exponents. So what we want to do is we want to write them with the same base so we can apply our exponent rules. So I'm thinking 4 to the power of 1 is 4. Okay, that works. 4 to the power of 2 is 16. Well, 4 to any, 4 to a power does not necessarily, doesn't equal 8. So we're going to go back and we're going to go to base 2. So 2 to some power equals 4, that's true, and 2 to some power equals 8. So we're going to take this problem and we're going to write it in base 2. Okay? So basically, I'm going to replace 4 with 2 to some power, and I'm going to replace 8 with 2 to some power, and I'm going to replace 32 with 2 to some power. So notice the only thing that I'm changing is I'm rewriting that 4 with a 2 to a power, I'm rewriting the 8 with 2 to some power within parentheses, and then I am rewriting 32 as 2 to a power as well. Alright, so 4, another way to write 4 is 2 to the power of 2. Another way to rewrite 8 is 2 to the power of, okay, if 2 times 2 is 4, 4 times 2 is 8. I multiplied 2 by itself 3 times, so that's 2 to the power of 3. And finally, 32. So if I know 2 to the power of 3 is 8, 8 times 2 is 16. That would be 2 to the power of 4. 16 times 2 is 32. So that's 2 to the power of 5. Alright, so our exponent rules say that if I have a power, that would be 2, raised to another power, we multiply the exponents together. So I end up with 2 to the power of 4x times 2. This is a tricky one. Think of this as being in parentheses. So 3 times quantity, x minus 1. That means 3x minus 3 equals 2 to the 5th. Okay? So now that all of our bases are equal, we can start doing a little more simplification. So on the left side, we can apply the multiplicative property of exponents. That means if our bases are the same, we can add the exponents together, okay, when they're being multiplied. So 2 is our base. There's a multiplication sign. That means we can add 4x and 3x minus 3 together. So 4x plus 3x is 7x minus 3 equals 2 to the 5th. Okay? The common base property says that if we have the same base on both sides of an equal sign, we can set our exponents equal to each other and solve. So we end up with 7x minus 3 equals 5, adding 3 to both sides. 7x equals 8, divide by 7 on both sides. I'm running out of room, x equals 8 over 7. And if I wanted to check to make sure that was correct, I would plug this back into my original problem everywhere I saw x. So I'm going to go ahead and do that really quick in my calculator. So 4 raised to the power in parentheses of 2 times 8 divided by 7 times 8 raised to the power of, and again I'm doing this in parentheses, 8 divided by 7 minus 1, and I get a total of 32. So that works. So you should get in the habit of checking your answers after every problem. Alright, the next problem where we have to use, where we're using a common base property is page 31, number 27. So we basically have two fractions set equal to each other. What you're going to notice is we have base 5, that's the smallest one, base 125, base 25, base, well, and then 3. 3,125. So what I'm noticing about this, if I'm just thinking out loud, okay, 5 to the 1, 5 to the 2. If you don't know this off the top of your head, you're probably thinking that might be 5 to the 3, and then probably 5 to something else. So we're going to be rewriting this in base 5. Okay, so I'm going to kind of set up my bars here. So I'm going to have base 5 to something raised to the 3x. I'm already in base 5 here, so there's nothing else to do. Okay, base 5 to something raised to the x minus 2 power. And finally, 5 to some power makes 3,125. Okay, so here we go. So let's start with the easy one. So 5 to what power makes 25? That is 2. Okay, so 5 times 5 is 25. 25 times 5 is 125. So that means I multiplied 5 by itself 3 times, so this is 5 to the third. Okay, so 125 times 5 is 625, so that's the power of 4. So I'm guessing this is going to be 5 to the 5th power. Okay, and it is really beneficial to memorize, you know, up through the powers of 5. Base 5 probably, you know, up to the 6th or 7th power, because these are pretty common. Alright, so let's go ahead and simplify from here. So we're going to apply the power on power property. That is, if I have a power, in this case 3, raised to another power, I multiply. So I end up with 5 to the power of 9x. My denominator doesn't change because we didn't do anything to that. Then I have 5. Okay, careful, I have to distribute that 2 throughout this entire binomial. So it's 5 raised to the power of 2x minus 4 divided by 5 to the power of 5. Alright, so now that we've done that, let's go ahead and we could go a whole bunch of different ways. We could cross multiply to solve. I'm going to actually use the quotient property because I think that makes it a little nicer looking before we start solving. So I'm going to say my bases are the same. So what that means is I subtract the exponent. So I have 9x minus x, that's 8x. What's really here is plus 0, right? So 0 minus 4 is negative 4. So be careful you don't accidentally write positive 4 here. Alright, and then I have base 5 here. 2x, well, there's a 5x plus 0x here if we want to think about it that way. So 2x minus 0x is 2x. And negative 4 minus 5 is negative 9. So we're just combining like terms in the exponents here. Alright, so when our bases are the same, we can bid them farewell and set our exponents equal to each other to solve. So 8x minus 4 equals 2x minus 9. I'm going to subtract 2x on both sides. So we get 6x minus 4 equals 9. I am going to add 5 to each side. So 6x equals 14. Divide by 6 on both sides. So x equals 14 over 6. And we should really simplify that to be in good math form. So we're going to divide the numerator and the denominator by 2 to write an equivalent reduced fraction. So 7 over 3. So x equals 7/3. Okay, again, you should put this into your calculator. Take 7/3, put it in for x in the original problem, and you'll see that you end up with one fraction that's equal to another. And that is how you do problem 27 on page 31.